Most of you have known identical twins that look so alike, but their personalities are completely different. They have the same facial structures, but they'll dress differently, they'll act differently, they'll have completely different interests. That's how I view isomers. Isomers are compounds that have the same molecular formula, but they have completely different behaviors, completely different chemical behaviors, different boiling points, different melting points. They'll react with different compounds in different ways. They are very important in particularly in the medical industry. It is important to be able to identify what compounds you are dealing with in order to predict the outcome of your reactions. Now, isomers can be divided into constitutional isomers, and these are isomers that have the same chemical formula, but the atoms are connected in a different order. And a perfect example are the ones shown earlier with neopentane, isopentane, and normopentane. All of these compounds have the same formula, C5H12. However, they all behave completely different, but because they're connected in a different order. So neopentane is methyl group connected to one central carbon. One is a straight chain molecule and the other is a branched molecule. These are what we call constitutional isomers. Now, stereoisomers are isomers that differ only in how their atoms are oriented in space. This means that their atoms are bonded together in the same order. However, how they are arranged in space is slightly different. For example, here we have cis-butene, which has 4 carbons and 8 hydrogens. Here we have another butene molecule which also has 4 carbon, 8 hydrogens with a double bond, and all the atoms are bonded to the same atom. However, one is called cis-butene because those two CH3 groups are on the same side of the double bond, whereas the trans-butene is on opposite sides of the double bond. This type of stereoisomer is called a geometric isomer or a cis-trans orientation. Now, isomers have very different characteristics. For example, fumaric acid and maleic acid are stereoisomers. However, their characteristics are greatly different. Fumaric acid is a metabolite in the body, whereas maleic acid is an irritant. Their boiling points and their melting points are vastly different. And the only difference here between these two compounds is how that C double bond OH group is oriented in space. Now, chirality is an important topic when we are talking about isomers. Now, if you look at your hands right now, you have 5 fingers on your left hand, 5 fingers on your right hand. However, if you attempt to take your left hand and place it over your right hand, that these molecules are what we call not superimposable, meaning you can't take them and place them on top of the other and get the same molecule. They are different. Your left hand is different from your right hand. We call this phenomenon chirality. And we say that a molecule is chiral if it has a mirror image that is different from the original object. And by mirror image, we say, imagine placing a mirror in front of that object. Can you take what you're seeing in the mirror and place it directly on the original object, and they match up perfectly? Now, a chair, on the other hand, as shown here, if you're looking at this chair in the mirror and you take the mirror image of that chair and place it over the other chair, you see that they match up perfectly. We say that a compound represented here by the chair is achiral. Enantiomers are non-superimposable mirror images of any compound. So by non-superimposable, what we're saying, as described before when we talked about chiral compounds, if you place the image on top of its mirror image, it will not line up perfectly. So molecules that have non-superimposable mirror images are called enantiomers. Here, the structure of 2-bromobutane is represented by this ball and stick figure. Here's its mirror image. If we tried to superimpose this mirror image, then it would not be possible. We see that they are non-superimposable. We call these enantiomers. Chiral compounds are always have enantiomers. Now, looking at 2-bromobutane, one of the ways to distinguish between a chiral compound is to look at what we call a stereocenter. Here, this compound has a carbon identified here with 4 different groups attached to it, and the 4th one is the gray in the back. This carbon, to which all 4 centers are attached, is called the stereocenter, or it is also called a chiral center. And this is one of the ways in which we identify chirality. Now, this is not the only way, but it's usually a quick way of seeing whether it's chiral or not. Usually, if there are 4 stereocenters, in most cases, then it is chiral. Mirror planes of symmetry. Sometimes compounds will have 3 different groups attached to a central carbon. That compound is achiral. This is because you are able to split that molecule directly down the middle through what we call a mirror plane of symmetry. For example, in cis 1,2-dichlorocyclopentane and trans 1,2-dichlorocyclopentane, in the cis molecule, you are able to split this molecule directly down the middle by a mirror because it has a mirror plane of symmetry. However, you cannot do that with trans dichlorocyclopentane because the molecule, when you try to split it down the middle, is not a mirror image, or it does not have a plane of symmetry through that molecule. These 2 molecules shown here for the trans 1,2-dichlorocyclopentane are enantiomers because they are non-superimposable mirror images. Diastereomers. Diastereomers are stereoisomers that are not mirror images. And these include geometric isomers, which we spoke of earlier, the cis and trans isomers, as well as compounds containing 2 or more chirality center. So, looking at all isomers, you can divide them into either constitutional isomers or stereoisomers. If it is a stereoisomers, then they can either be divided into enantiomers or diastereomers. Diastereomers are further divided into geometric isomers, which are the cis and trans, or other diastereomers, such as meso compounds, which we are not going to talk about here. Thank you for listening, and I hope you found it very informative.